Good morning, everyone. I'm Shehna Sagaria. I'm the project engineer at Space Structures in Berlin, and I will be presenting the pilot experiment for change to twin, that is the prothesis adapter, creating and deploying the digital twin. Space Structures GmbH or SPS is in Berlin, and it is an engineering solutions provider mainly for space applications. We provide solutions from product launch to its deployment, including a sophisticated product development process. SPS portfolio also includes different other products like engineering analysis. We have Spaceport, a tool for bolt verification. We have CFRP struts, panels, different structural assemblies built to spec products. Now, moving on to the change to twin problem statement. For change to twin, we are considering to develop a prothesis adapter as the use case. Here, the adapter is used to connect the knee hinge to the carbon fiber foot for the para-athletes. The production process at SPS is unique in the terms of we have a very low batch size because it is a build-to-spec product. So this is one of the main parameters that influences our production development. Now, these main parameters help us to identify the main KPIs for the product. And here you can see the product development cycle that we usually use, and kind of interlinking the product development cycle to the main requirements, we come across to our KPIs, which is what we have in this particular section here. Now, based on the KPIs, we kind of come across into it for the product development and how we can use digital processes to improve our production process. Now, also the KPIs drives the decision on the requirement and the technology to be implemented. Towards the solution approach. The first step towards the solution was to identify the main problems. And we have identified the main challenges for each production processes and prioritize them based on their contributions towards the KPIs. And then what we did is to identify the possible solution providers who can help us tackle all these different problems. First provider that we looked into was towards requirement tracking and data storage. And we come across Yotness TruePLM, which is used to track changes in requirement, design, and have it updated in the downstream processes. TruePLM is integrated with ISO 10303 step standards, which help us to provide platform for a unified data exchange, sharing, and archival. Now, going into the next problem, which is to have a design which is optimized for manufacturing. For that, we kind of used the help from additive industries, and they helped us to align the design to the manufacturing parameters. And it is mainly done through design checking, providing product manufacturing information and limitations, which is available for 3D printing, especially for metal 3D printing, which is the technology that we use to make this product. Now, next comes the computing challenges. Here, we have used the help from Cloud Broker, and we use their high-performance cloud service to run complicated analysis and to have a faster results. It helped us to reduce the lead time for product development. That was very helpful overall because time is always a constraint when it comes to the product development cycle itself. Now, moving on to the production itself, we have the 3D metal printing facility from Additive Industries, and they helped us to do the production of the prothesis and also the post-manufacturing processes like cleaning it and to have proper finishing for the product. And then the testing of the product itself was done at the Space Structures. We have in-house structural test facilities, which we use to do the structural tests like stress test and fatigue test for the product. Now then comes the main important part here, which is the test data correlation. It is important to have to access how good our digital twin is and how good our twin is relatable to the actual product. So we have considered two different methods for test data correlation. One method is a tool used by Yatna, which is called EDM OpenSimDM, which helps to overlap the analysis data or the digital twin data with the CAD, and then to have the test data overlapped into the overall system so that we can see how the digital twin is with respect to the actual data. And it helps us to correlate it better and to have faster correlation also. And another method which we considered was photogrammetry, which was the technology implemented by TNO. Here we were using 3D sensors or 3D imaging technology to have to construct the whole system in a 3D mapping way using image sensors. And overall, these particular products helped us to have a clarity on how we can tackle our problems. And these were implemented for this particular project in Space Structures. If we talk about the impact of implementing these softwares, the main aim for us is to realize an effective digital twin. And by implementing all these tools, it was achieved, mainly because we have improved a lot on our KPIs. This enhanced digital twin helped us to obtain a better correlation. It helped us to have a better correlation not only for the product itself, but also to improve our basic parameters used for the digital twin setup itself, so that we can use this for multiple products. So that was a big advantage that we came across through this project. This also helped us to improve our KPIs. And here you can see the variation in the KPIs that we found through implementing. And here we have overall, we were able to provide better products faster and hence with the cheaper prices. Now, going into prothesis testing. Here we can see we have two different testing going on. So here is a stress test where we were able to see how the performance goes on during the stress of when it is working on when someone is running using the adapter. And then here we have something called the fatigue test. What we do is we try to keep on loading to see how much is the maximum load the prothesis can adapt. And we can see it's at some point it breaks, but this is like the maximum load consideration that we use. Not so important, but we use this to kind of go back and see how good our design is and to see whether these are the results given by the digital twin. And we were able to correlate in a very better way, and it really helped us. Now, we are done with implementing the technologies through the change twin paradigm. And now what happens with the project further is we are looking more into using fiber optic sensors on the test object so that even we can get the very minute variations in different parts of the component. And the EDM SimDM tool, it helped us in a way that we can easily feed the data into the tool and we can have the variations. So it enabled us to use the data in a very efficient manner. So even though we had the data, it was not always easy to use it into a digital twin and correlate it better. But now we were able to do that, and we can use these variations to update the parameters or like update the analysis parameters so that we can have like a better settings for the digital twin itself. So it's more like fine-tuning the settings, initial assumptions, fine-tuning the baseline. So we are planning to use this fine-tuned parameters as a baseline for our future projects. And now moving on to the lessons learned from the project. The first and foremost was we have to figure out what our KPIs are, and this has to be done during the initial phase of the project because this kind of goes through a long way into finding out what because there are so many technologies available and it becomes like we wanted to implement them all. So it always comes back to what are the priority and what is that you want to do within a particular amount of time and what is possible. There is no point in starting to implement a technology when you don't have enough resources or time to have it completely implemented. So it always helps to understand the KPIs and to have a time check or a reality check on and prioritize on what is possible and what can be implemented. And then comes cross-check for development and implementation time. You really have to have a clarity on the possible delays that could happen. So when you're working on any project, you will have problems with lead times. We came across because our project was deployed during COVID times. There was a lot of problems with lead times and getting some resources in terms of raw materials, even to have components shipped. So these are some parameters that we have to keep in mind when we try to implement a new technology and into a production process. Ensure that you have enough lead times, you have enough time, or you have to make a plan in the way that even if you come into delays, you can have at least a part of the technology implemented so that you can use them. The main part is deployed properly. Okay, and I think these are the main lessons to be considered, just to have proper planning, clarity on what is required and what is possible, in short. So this is it. So we were able to have digital twin implemented with the help of all our wonderful partners here, and we were able to use Change to Twin products for developing our digital twin. And to help us, it really helped us to improve our product development process and to have this main thing that we were trying to do is like the first time right product. Thank you.